Okay, sorry, back, readjusted the screen. So yeah, here we go. Like I said, as you can see, I'm in the IDLE, and I'll go ahead and run this. Way slow. That took 32 seconds to calculate. Wow. Now, I'll go ahead and show you in the MU here. Oh. Okay. So as you can see, same code. Everything's the same. You can pause the video if you end up really wanting to check me. It's fine, I don't care. But yeah, let's see how fast the MU editor does this. Yeah, that's more like it. Took 0.196058, and actually if I keep running this, it can get pretty crazy fast. So yeah, 0.14, 0.14. That was a little slow. 0.17. I had it at 0.12. It's like the fastest I get it. Oh well. As you can see, that's what it should take. So why, if I'm going here, bring up the IDLE. Look at the difference. Why is Python's 3.9.0 shell IDLE take 32.59894 whatever seconds to calculate, when MU editor takes 0.14? That's insane. So, I mean, if I was, Apple trying to bash on Python, I would just use the IDLE 3.9 and say, yeah, look at how slow Python is. But the truth is, it's just the IDLE. It's not actually Python. It's not the actual code. Now, just picture for 1 second. Now, I only wrote this in the IDLE before realizing this. But here's I was just working on a basically autonomous debugging bot, if you want to call that. So how it's implemented is, I'll pull up the other files real quick. Okay, so this is object-oriented programming here. So the basis starts right in here. And this is where I kind of define my basic players. I have my parent class here, class player right here, that goes through. And something I do a little bit different than probably most people, I don't use print functions that much because, one, print functions take away from the timing of everything, and I can get a lot more information by using logging. And then when you have your own logging debugger inside of Python or inside of IDLE's debugger, I basically can pinpoint anything that goes wrong almost instantly. I'll show you examples in other videos later, but main point is this is the first module, and then Bunko module 2, this is the second module. Now I had to make a second module because it was just easier to implement. I wanted to basically probably confusing you. Basically I wanted to go ahead and if you notice in this module here, I create a whole another class. Now this class basically inherits from this class here, this cheat swapper class. Or no, I'm sorry, this computer swapper class. Now the computer swapper class, it inherits from player, so computer cheat inherits from computer swapper, which in computer swapper inherits from player. So as far as object oriented, we have about three different instances of inheritance. It makes it very fast, and even though it looks all kind of like nuts when doing it this way, I can sort of create classes on the fly, and yeah, if anybody wants to learn object-oriented programming, guess you could say the hard way. I think this is the easy way though, to go ahead and just kind of experiment and do more than just one inheritance instance. But yeah, it's a pretty complex thing, so trying to if something goes wrong, trying to debug it, because really the program that I run here is called a Bunko single test here. This one here actually goes into Bunko module 2 here, and it goes into Bunko module and Bunko single test. It actually jumps in and out of all three, including itself. So it's weaving a very complex pattern, very hard to follow. And if I just said, here's Bunko single test, you can use this module or whatever, and then its dependencies are using two different modules, and I didn't use this debugging protocol, you'd be like, okay, forget this module, I'm not using this. Like, I'm getting errors everywhere, and I don't even know. It just says error, string error. I don't even know what to do. So I basically solved that problem by creating three different logging debuggers, which each log in itself or logs each module. So every time Bunko single test goes into Bunko module into a method like roll_2 or roll self. I have it all linked so that even though it's pulling from different modules, you just turn on the logging, and then it lets you know, okay, I'm pulling from Bunko module now, and now I'm jumping to Bunko module _2. Now I'm jumping and printing functions in Bunko single testing. Yeah, it makes it real easy to see what your actual program's doing rather than being totally in the dark with it. And that's the kind of experience I experienced with learning Python initially, and I think it's kind of awful to say, hey, learn Python, and then you're gonna have to download this module. And so what you're going to do with this module is import it and define a function like this, and then all of a sudden that module's been updated to the new PyPy whatever or Python 3, and then you can't even use their examples, so you're just like left in the dark to figure it out. I'll show you an example of exactly what I'm talking about in a later video. I'm probably talking way too much. Anyways, yeah, so I'll show you how make sure that the logging's on all these. Yep. Yep. Okay, so we start here with our base module, right? This is where basically our first class is started, and our first class is player. It does import. Don't worry about this import re. That actually I had to import that to basically get a regex, which I'll talk about later. A regular expression matching. But it like seemed to sorry about that. So it seemed to basically I lost my train of thought. Anyways, oh yeah, so I had to import the which is regex, regular expression pattern matching, which I use later on in this session. I'll show you that later. But I had to import it in my base here module. You could call this the Genesis module, and I had to do that because I was having problems with separating out stuff, which I'll show later, and I found the solution to it, and it was all because I found the solution within about 2 hours, all because of this way of debugging. So yeah, on to show the actual how the code works. So I'll run this here. Yep, of course. Okay, so as you can see, so I get, when I run my code this way with this debugging, I get an instant notification that a call to Bunko module has been made, and I also get a notification that call to init function, right? So I know that this module is ready. It's ready to go. It's like imagine a first baseman trying to steal second. You know, he's tiptoeing towards second base. He's not running yet, but he's ready to go. That's kind of how I imagine, just giving a real world example, I guess, visualization to what this here actually is meaning, saying that that it's ready. The call, basically the way I coded this is that rather than having to call to init function by running it this way, when you import it into this example right here, you can see as I import my Bunko module here, I already have basically an instance ready to go. Probably over explaining it. Anyways, so we go here, Bunko module 2 here, and then we'll run module. So that's just the um, the first child, if you want to say. We can say generation. I don't know. Yeah, we'll say Gen 1. So in, well, we'll say this is Gen 1, just to simplify it, because I already have this labeled Bunko Module 2. So Gen 2 here actually starts making calls to back and forth in itself, as you can see here. So it's actually doing work now. I hashtag these out because I only want to see right now cheater 1, cheater 2, and I want to see what the computer rolled. So anyways, so yeah, okay, so here's where things get complicated. So as you can see, with this debugger, I can know that that end of call to computer cheat, computer rolled, and then computer rolled these. By the way, it's rolling dice, if I didn't explain that yet. But so now I have some get dice function calls. So this is telling me that it's going not it's not working in Bunko Module 2 towards the end of it, but rather it's working right towards the end of the program. It's working in here. Specifically, you can see here I have right here, get dice function called. All right, so that's what this debugger is showing, that we have 1, 2, 3, 4, 5, 6, 7, 8, 9 calls to get dice function for whatever reason. Now you can say, oh, you need to cut that out, and you need to that's going to make your program too slow. Well, just wait 1 second. It's, like I said, it's a pretty complex thing, and I'm pretty happy that I got it this far. So anyways, for so right here, let's try to find those get dice function calls. Oh, as we can see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oh, but it must be skipping one of these here. Yeah, it has to. I set this up to skip this on purpose. This is to be implemented in another, so let's say Gen 4 or 5, that will call on and inherit from Bunko Module 2 and inherit from my next Gen 3, which I'll show you. Anyways, so there's 10 here, but obviously these are getting skipped, and that should add up 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah, it looks like 1, 2, 3, 4, 5, 6, 7, 8, 9, and I don't. One of these must be getting called somehow. I'll have to put a logging in there later, because that doesn't really make sense to me. Anyways, so we're pretty close though. The main point is that I know I know exactly where my program stopped, and that's right. See this print total computer 0. I know, okay, right here. So obviously I have a lot of stuff being called going into this class that I created inside a module that not only works in itself but makes and inherits from a class of itself, if that's even the right terminology. I don't know, but you can see that I put logging debuggers all through here. So even this is very important. So right here I have debugger that lets me know that, you know, computer cheat has started itself, or has been basically, a method has been placed where it has to call itself. It's a function. I don't know the right terminology. Half the people tell me it's methods, half people tell me it's a function. It don't really matter. I mean, maybe it does matter, but for this example, you can just see how it works. So basically, I'm putting a logging debugger here to let me know if it's made it past being implemented. That's the best terminology I have. I will be notified when something has called upon computer cheat and it is now starting or implementing its process, which will go through all this stuff. And if it breaks at some point, I have debugger to let me know at every point, okay, it broke at this point, it broke at this point. And that's kind of how I coded this and worked through this, you know, big mess of code. It was actually fairly easy to understand, and also fairly easy to understand exactly what's going on in my object-oriented paradigm. So anyways, you can see that I did get a start of child process computer cheat, which inherits from computer swapper. So I'm right here. So I did get that, but it skipped right past all this stuff and went right down to end of call to computer cheat here, as you can see. So now I know that although it initiated itself just like I showed you in the actual, you know, Genesis module, it's just ready to go, but it hasn't, you know, started running through its process, running through its defined cheats, running through its defined rolls of dice and how it implements that. So real quick explanation before I get to the final presentation. So basically what I created here is computer cheat here inherits from computer swapper. So computer swapper just takes its dice, and if cheater 1 or cheater 2, cheater 1 has 10 dice, cheater 2 has 10 dice also. Now total computer 0 has 20 dice. Now basically the goal of computer cheat is to make sure that cheater 1 and cheater 2 lose always. So basically the idea of the game is cheater 1 will pick 10 random numbers, which are defined in rolls of dice, just so that I can basically have the computer play itself. Same thing with cheater 2. If as you can see here, if the computer's total, well, really not the total, but if any of computer's dice rolls match one of cheater 2's dice rolls or cheater 1's dice rolls, then obviously cheater 1 and cheater 2 have won, and computer computer has lost, essentially. So if we just went with the computer choosing random numbers, the computer could basically not, like, very rarely win unless cheater 1 and cheater 2 were like totally stupid and just picked like their favorite numbers or something. So to make it harder for anybody who wants to play this game, I created this here class, computer cheat. And what it does is it uses rejects, it uses listing, it uses copying, it uses, all sorts of stuff, like everything in the bag for pattern matching, to basically find if any of computer swapper or computer's dice are matching cheater 1 or cheater 2, and if that is the case, then it automatically makes sure that's not the case, so that cheater 1 and cheater 2 will always lose. And surprisingly, this program really fast. Barely. I'll show you once I take the actual logging off how fast it actually goes. So anyways, you've seen kind of the basis. I've explained most of it. I'm going to go ahead and run the final part here. Okay, now eventually this gets implemented into, you can see it says bunco single test, but eventually this process will be implemented with I don't know, hundreds of thousands of dice, and then it'll basically compute metrics back, telling what cheater won versus the computer, and how good the computer was able to, or how fast the computer was able to play this rigged game where it swaps its dice out so that it's that cheater 1 and whoever cheater, it's always different and they can never win. So basically the idea is to see, one, when the project is fully done, one, to basically get data to see how many cheaters it would take to beat a computer that is essentially also cheating, and also how many how much basically can the computer actually juggle, to see if it like messes up in some way by trying, basically what's a better tactic here? Is it to throw a bunch of players at it, or is it should you go with something more finesse? And it also will have financial data that will be logged for every simulation. And I ran a basic simulation, not with all this complexity, but with simple complexity, with million different games, not with the complexity of the actual computer, trying to make sure that the cheaters lose, but just one cheater and the other versus the computer, and yeah, it was just too easy, and didn't give really enough data that was worth, it just wasn't a good program, I thought, and I wanted to see more data, and I needed more complexity, so that's why I created this. So anyways, here comes the final Gen 3, so just one test of multiple inheritance object-oriented programming, all with automatic autonomous debugging. Yep, so you see. So, yep, worked perfectly fine, as you can see. Anything that is just a debug statement is usually good news. When you have the debug statements, and why it's autonomous is the debug statements tell me where my program actually fell through. Not exactly where my program's going wrong, although there was instances of this did show me that. But rather it's just to keep track of where I'm at, like running a finger, because the program runs too fast. I can't keep track of it. The autonomous debugger allows for me to keep track of where I'm at in a program when I'm going into multiple threads and multiple different generative modules that are calling in and out of itself. It just gets too crazy. So this was my solution, and I think it's pretty cool. And also, as you can see, you saw how complex that is. Look at my time profile. Yeah, I had a same profile that we did there before. I said here's a start time, and I only need to set a start time for this one. I don't need to set it for any other ones, because this is going to be reaching in my other modules. So it only matters when this ends, which is right at this point. And yeah, if you tracked it with a stopwatch, which you can, rewind this video if you want and track it with stopwatch. Yeah, so all that complexity, 23 seconds. Now real quick, I'll show you, go ahead and just take, this is also really what's nice about having an autonomous debugger like this, or using just debugging in this format. I say autonomous because I'm not really trying to sound fancy at all, by the way, whoever's listening to this. It's natural for me to say autonomous, because eventually I'm going to create GUI bots that can debug a program itself. I'll give you a little peek about that later on. But anyways, so I'm going to go into all my modules here real quick and turn off the debugging. I'm just going to run it real quick, just make sure. Okay, so you can see I didn't get the debug statements. I still got the debug statements in my my Genesis module, but that's because I haven't turned the debugging off yet in that, so that's fine. I can go ahead and exit this out. Bring up this here. And then when I run this, I should not get any debugger information. Okay, as you can see, debugger information gone. Go ahead and exit that out. Now, watch the time lapse. Mind you, with an IDLE, as we saw, took an excruciating amount of time to loop through a basic for loop. Just imagine, now I haven't got all of the paths set in MU editor, but just picture with a good IDLE like MU editor, what you could do with programming like this, a programming structure like this. Less than 1 second. So if I take all the delogging off, which is, as you saw real quick, the logging is just for if there is a problem. So if I'm getting any, I'll give you an example. We'll go here. Let's say I get, I'll just take this out, or no. Okay, we'll make this string an integer. No, not a good example. One second. All right, we'll make this. I just don't like it. Let's go ahead and go into. I like the example right here. I experienced this just like a day ago. Here is a good example. So I'll set the logging off here just by hashing it out, and then we'll go here. We'll just say here I equals 679, I don't know. Actually, -1. We'll just do I equals -1. See if that works. And then we'll hash this out, because I know I'll get something there probably. Kind of funny. It's kind of harder creating problems once you get them like this. All right. So now I should get a problem. Don't get a problem. That's just great. Oh well, it hasn't called itself. Okay. So as you can see, if I just ran it like this, because it hasn't gone into its class method that I created here with computer cheat, everything looks, hunky-dory. So we just go ahead and turn the logging on here. And I'll run this, and I should get an error. Is that right? Oh, poopy poop. Well, maybe I need to go all the way back into my oh, here it is, original. Yep, that's probably it. Well, that's pretty cool. If it is what I think it is. Like, so they're all still connected. That's pretty cool. Yeah. Imagine downloading this module. And then you're like, oh, I'm trying to use that debugger. So I'm hoping I get some kind of bug here. Or it might be on a, it's on a loop, I think. Yeah. Yep. Interrupt execution. It did not stop, so that's how I know. Okay. Yeah, so if you guys ever wonder, okay, am I in an infinite loop when you can't see all your information? If you go ahead and try to hit interrupt execution and the program's like, screw you, and just keep running off, yeah, you're in an infinite loop, which is kind of usually bad, unless you're doing streaming JSON dumps or whatnot. So yeah, anyways, I'm going to go ahead and restart the shell. That usually does it good. Yep. So I was in an infinite loop right in I don't know why it went away. Must have deleted it. Okay, so we'll go I equals let's go 2. See if we get something now. So this code should complete just fine, even though I just put a bug in there on purpose. Like I said, the way it works is it's still a class that gets called after it runs through itself. So go ahead. I got nothing. Okay, so as you can see, definitely have some weird sort of bug here. There was something there. I don't know. Maybe it skipped right over it. Give me some kind of break. Yes, there we go. Aha. So, this is the main point I wanted to show you. So, you can see name 2 is not defined. So I get here. You can see kind of the benefit here. I get line 38. That is not going to work, apparently. And line 97 in so line 38 bunko single test, which line 38 right here. So that is the is where the class is being called, or where it's being given an argument of its cheat. So this is the start of computer cheats. cheat that's being initiated. So that's really helpful to know that, okay, it tried to call that. But then it also goes into bunco module _2 here, and says line 97. So it gives that basically in your current module, what is trying to basically, it's trying to work this in the current module, but something in another module, which gives its exact line, is preventing it from being able to complete its task right here. So this is actually a really great example. So now I can take this back to, and then, you know, knowing both these, that information now, I should be able to go ahead and I'm going to run that just to save it and update it. Okay. Now, that should give me enough information to basically automatically fix whatever problem was there. So, oh, sorry. And it completed just fine. So now you saw the full picture of the automatic debugger. I will pull up one more thing to show you here. Just to show you what I mean by how this will all, like, eventually be an autonomous debugger example program, but also it'll still be a cool program, because maybe you could just use it in you know, doing some quick number maths if you're trying to, you know, win some money, you know, in betting, if you catch my drift. You know, you could definitely take this to, I don't know, the Grand Slam, you know, style of like online betting for your specific state, whatever that is. That's all the hints I'm going to give anyways. So we'll go here. Sorry, 1 second. Okay, we'll just do this one here. So, real implementation. Oh yeah, this is actually perfect. So now this kind of takes forever, like I said, because of the IDLE. But just think about the possibilities with, you know, formatting this code I have here to be an autonomous debugger, while also the speed of object-oriented programming in, you know, an actual thought out IDLE or IDE like MU editor. And maybe that's my problem, is I'm trying to compare an IDLE to an IDE. I don't know. But the whole idea of this is showing you different how fast you can really get your programs going. So even if I'm using the wrong terminology, hey, I still think I got some pretty cool programs here. So yeah, so I'll run this and you can kind of see how this goes. So by the way, I'm not, you can see my mouse isn't touching anything. Yeah. So it's literally automatically clicking through all these web pages. And this was an original supposed to be learning experience that I was like reading out of this book, and yeah, none of their examples worked, so I made my own example, and turns out it's faster than their example. So yep, with an IDLE. How about that? Probably could go pretty fast with a MU editor, but yep. So anyways, this goes on for about, a few minutes. It'll go through every possible web page here, and yeah, that's it. So hopefully you enjoyed. Hopefully you think this is pretty cool, and if you got any suggestions, go ahead and shoot me a message, or if you want a program made, you can go ahead and contact me. I'll leave the necessary contact information wherever I decide to put this video. So yep. All right, well, I guess that's it. I'll leave this play, let it play out all the way, just so you can see that I have a debugger here also. Yeah. Oh, in case you're wondering, like, oh no, there's no failsafe. Yeah, there's a failsafe. Always first failsafe. So, oh, also, if you want to learn to program something like this here, that can, scrape web pages. Turns out there's a lot easier way to scrape the web. You don't need to download all these crazy modules, and I programmed this I think in less than 5 lines of code. So yeah, the more high level version of this actually downloads every single web page and then uses a regex to scrape text from the images, sorts it all out, and then then I can, as a data analyst, I can now say, okay, how many times was letter R in all these pictures? So that's the more full implementation, but I'm not going to show that code here. Yeah, if you want something built like that, I can promise you I can build that, but yeah, some of that code, yeah, I'm trying to make some money, I guess. Or I am trying to make money with programming, so this is actually my first tutorial slash I don't know what you would call it, exhibit of my skills, maybe, but also maybe inspire some coder that's out there that's thinking like, oh, this stuff seems so crazy hard and I'm just trying to learn on myself. Yeah, I feel you, I understand, and like for me, it was just realizing that all the tutorials that I tried learning were already outdated by the time I was reading them. So, and that's kind of how coding is, because things update so fast. Like, there's no reason to even have all these coding camps and whatnot, because you're already behind schedule after a month of trying to learn code. What I would suggest is, or at least this is what I did, I learned how to basically implement the basics that I know will work all the time, regardless of all these updates and whatnot. And then definitely learn how to work in the terminal. So a lot of these calls are being made inside the terminal, even though it's showing IDLE. Yeah. Terminal helps a lot because the terminal doesn't really change regardless of any updates that happen to your computer. And iOS might be a little bit trickier, but it's looking like Swift makes it kind of easy. I've used Kivy for iOS and Android for a long time, but I'm thinking about trying out Swift, even though they tried to dog on my Python, which I didn't appreciate too much. But yeah. Anyways, yeah. Well, I'll let this play out, and yeah, thanks for listening, and hopefully I didn't rattle your ear off rambling. So, yeah. Well, thanks for watching, and if I make this YouTube, you know, the whole, don't forget to subscribe. And I always try to convince you or whatever. Yeah. Alright. I'm back. I didn't like that bye, so we're gonna do goodbye. That's better. you're fine.